What makes a good Nobel Prize winner? Perseverance, good luck, good mentors and students. Here's one possible factor that I never would have imagined in my wildest dreams: chocolate consumption. Chocolate consumption tracks well with the number of Nobel laureates produced by a country. At least that's what a paper published in the New England Journal of Medicine claims, and that's one of the world's premier journals on medical research. In any case, a plot of chocolate consumption versus Nobel Prizes reveals a strong positive correlation of 0.79. Now, Sweden is potentially an outlier, and the author thinks it could be a result of patriotic bias from the Nobel Committee. Take it out and the correlation improves to 0.86. And this graph represents all its, the relationship between chocolate and Nobel Prizes in all its glory. Now, just because chocolate consumption is related to Nobel Prizes does not mean that chocolate consumption causes Nobel Prizes. In other words, just because A is related to B does not mean that A causes B. It might be that B causes A, or more likely, there may be another variable that's causing the relationship. For example, the Scandinavian countries rank at the top of the graph on the right, and they are known to rank highly on both Human Development Index and per capita income. So perhaps higher chocolate consumption means greater affluence and an improved lifestyle. Put simply, people who eat more chocolate are likely to be better off and perhaps even happier. Greater affluence means better and higher education, research opportunities, and perhaps Nobel Prizes. But remember, correlation does not equal causation. Did you know that the size of your palm is negatively correlated with how long you will live? In fact, women tend to have smaller palms and live longer. Or another example, it's been found that there's a strong positive correlation with the amount of ice cream that's sold by street vendors and drowning. But this relationship does not imply causation. Whenever a correlation between two variables occurs, there are three possible causal explanations. X causes Y causes X, or another variable or variables cause a relationship between X and Y. So in the chocolate example above, another variable such as wealth of the country may cause a relationship between chocolate and Nobel Prizes. In the case of hand size, it's a negative relationship to life expectancy, where females typically have smaller hands than males and also typically live longer. Or in the case of ice creams and drownings, you've probably already figured it out, but a separate variable of temperature is likely to play a part. So please note that just about everywhere, correlation and causation are easily confused. Our minds are trained to find simple, easy, articulated patterns. So we often look at the relationship between the two variables in a vacuum, forgetting that in real world, quantities are affected by a multitude of different factors. The next time you read two values are connected to one another mathematically, remember that the real world quantities are produced by a tremendously complex system of different influences. The correlation you see does not automatically imply causation. This is a great weakness of correlational research. Causation cannot be inferred from the correlational research design or statistic alone. You are permitted to argue causation on logical grounds, provided you make it clear that your conclusion is based on argument, not demonstrated by the research. Often, for example, you can rule out Y causing X because it's logically impossible. You may also be able to offer a strong logical argument in support of X causing Y, but you can never be absolutely certain about the possibility that other variables are playing a causal role. Whole research programs are often devoted to identifying and understanding the role of other variables. So please don't ever forget this, and please don't just rote learn it. Remember what it actually means. Even though nearly all students can happily recite correlation does not equal causation and can answer these questions correctly in exams, if they do correlational projects in fourth year or masters, they title them something like the influence of X on Y or the impact of X on Y. Words like influence and impact essentially mean cause, and the whole study proceeds to imply causation, often with no reference at all to the correlational and causation problem. The title should have been something like the relationship between X and Y. And not only students do this, academics and professional researchers often do it as well. You even find it happening in published journal articles, and it happens, as you're probably aware, nearly all the time in media reports. Let's look at the example of a bivariate correlation with SPSS. So with the SPSS, what I'm going to demonstrate is a point and click in SPSS, and also demonstrate what the output means.